Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. For this video, I'll be specifically talking about combustion reactions. Quick little update: Facebook fan page, link in the description box below. Check it out, show your love and support, like the page, tell your friends and family about it. Also, I've been getting a lot of questions about can I make a video on this or make a video on that. What I want you guys to do, if you guys have any specific questions, I want you to check this video out. I'll put it in the top right hand corner of the video. It's called Quickie Update. It's going to outline and explain to you what type of questions I'll be willing to answer, okay? So check that video out, and then we can go on from there. Other than that, let's get started with our discussion on combustion reactions. Now, a combustion reaction typically takes the form that I have shown up top here, okay? You just need to memorize this equation, this reaction. But it also should make sense from real life experiences, okay? So we'll go through each and every one of these components. The first thing I have in quotes is known as a hydrocarbon. A hydrocarbon is a species that typically consists of carbon and hydrogen. And here's an example of a hydrocarbon, as you can see here. And this is known as propane. Another hydrocarbon is ethane, methane, butane, what have you, okay? Those are hydrocarbons. It consists solely of hydrogens and carbons. Now again, I said that the reason why I put these quotes here is that you don't need to always have only hydrocarbons. You could also have other species as well. It's not only limited to hydrogens and carbons. You could also see oxygen present as well, and you'll see an example a little bit later as well. Also realize that this state, the G state, basically the gaseous state, that's what this represents in the parentheses. It does not always have to be in the gas form. It could also be in the liquid or solid form. That's something to realize. But for the rest of these guys, you'll always have O2 gas in the starting material section, in the reactant section. You'll always generate CO2 gas, and you'll also always generate water in its liquid form, okay? And again, those are what those letters represent. It represents the state of the molecule. And again, another side product that you generate from this reaction is a lot of heat, okay? It shouldn't make sense. A combustion reaction, you generate a lot of heat, energy, all that good stuff, okay? So let me just talk about an example of what a combustion reaction looks like, okay? You have a gas stove, okay? You open up the knob, the gas is being released, it's mixing up with the oxygen present in the room. You get your little lighter, you light up the gas is being released, and bam, you have this reaction that's taking place. You generate a flame. The flame is being supplied by that constant stream of fuel, which is your gas, and that's effectively a combustion reaction, okay? Other things you generated clearly is the CO2 and water, but obviously we don't see those things present when we're looking at our stove. We only see the flame, and that flame is that heat, that immense amount of heat that we generate from that reaction, okay? And that's your typical combustion reaction, reacting a gas typically with oxygen, and you get some sort of flame, some energy, and you get these other things as well, okay? So combustion reactions are very simple. If your teacher asks you write out a combustion reaction for propane, ethane, whatever it may be, you should be able to write it out very quickly. Put the O2 here, the CO2 here, the water here, because that's what the reactant is always going to be, and the products are always going to be water and CO2 in those specific states, okay? So remember that combustion reactions are extremely simple because you just have to memorize this segment of the board, plop it right here, and you're done, okay? The most important things that you can take away from watching this video is two things, okay? Knowing what a combustion reaction is and how to write it out, okay? And that should be quite simple. And excuse me, and knowing how to balance out equations, okay? What is balance? What do I mean by balancing out equations? Okay, so again, if you're just a introductory student in the field of chemistry, some of these things might be a little bit new for you, so I'm going to go through systematically to explain what it means. Balancing equations basically means you want to have similar amounts of atoms on the reactant sides as you do on the product sides, okay? So if, say for example, we have 5 carbons on the right side, we want to make sure that we have 5 carbons on the left side as well. Let's just say we have 7 oxygen atoms on the left side. We want to make sure we have 7 oxygen atoms on the right side. And there are two main reasons why we want to do that. The second one, which is calculation, is an added benefit, but the first one, conservation of matter, is extremely important, and that's what it is. Conservation of matter, basically, it's a law, and it states that matter cannot be created nor destroyed. So for example, let's just say we have 10 grams, or let's just say we have 5 grams of a starting material, and we convert it fully to product. Okay, we convert all that starting material, all our reactants, fully to product. Now we should expect to see that 5 grams of starting material in our product. Okay, that's what the conservation of matter is basically saying. Same thing could apply to atoms. Let's just say we start out with 5 atoms and we convert all those 5 atoms to product. Okay, we should expect to see all 5 of those atoms we had in our reactant side in our product side. So you could clearly see how the conservation of matter is playing a role in this, because there's always going to be this balance of the left side to the right side. You're going to have 5 on this side, 5 on that side. And that's the whole idea of conservation of matter. Matter cannot be created nor destroyed. Okay, and this is just a law, and you guys have to accept it. So a way that we could apply this law is the fact that we need to have balance on both sides. Another thing that is extremely important, but it's just a added benefit from the first aspect of it, is calculations. By having things balanced, it allows you to calculate certain things, and right now that's kind of a very general statement I made, but you'll see the importance of having things balanced in the long term when you want to do certain calculations. Okay, and these two things apply to every single reaction you can think of. It doesn't only apply to combustion reactions, it applies to every single reaction. Okay, so let's do an example. Okay, your teacher says, here you have propane. Okay, so again, the most important things you can take away from this video is knowing what a combustion reaction is and how to draw it, and how to balance out things. So let's just say your teacher says, I want you to write out the combustion reaction for propane. So here we have propane, which is a hydrocarbon, and we want to write out the rest. The rest is pretty straightforward. Remember, oxygen is always going to be one of your starting materials or reactants, so that's synonymous for one another. And then we have carbon dioxide, gas, plus water, liquid. Very straightforward. Now we wrote out the reaction. That's the first part. That's extremely important, but now we have to balance it. Clearly we can see we don't have balance on both sides. As you can see, we have 2 oxygen atoms here, we have 3 oxygen atoms on this side, so it's not balanced. Okay, so when it comes to balancing things, you guys will see a little bit later on that is all about trial and error. There's no rhyme or reason to it. You just have to play around with things. But just a little bit of structure for you guys. The way you typically want to balance out combustion reactions is start out with carbons. Try to balance out all your carbons first, then all your H's second, then all your oxygens last. Okay, that's how you want to typically do it, and that's what we're going to implement right now. So as we can clearly see in the reactant side, okay, where the arrow is pointing away from it, which is this side right here, we have 3 carbons. On this side we have 1 carbon, so why not put a 3, which will be our coefficient. Okay, these are known as coefficients, the number we put in front. Okay, and these are used to help balance out one side to the other. Okay, so again, we have 3 carbons here. We're going to put a 3 here to have 3 carbons on this side as well. Now the carbons are all balanced. Now we're going to move on to the next thing, which is hydrogens, right? C's, H's, then O's. So we have 8 hydrogens here. We have 2 hydrogens here. Now if we put a 4 here, that balances out. We have 8 hydrogens on this side, and realize the coefficient in front is multiplied against this species. Okay, it's not added, so it's not 6 hydrogens. It's a multiplication. It's a product. So instead of 4 plus 2, it's actually 4 times 2, which is 8. So we have actually 8 hydrogens on this side now by putting that 4 there. So the hydrogens are all balanced. Now the next thing we need to balance out is the oxygens. We have 2 oxygens on this side. We have 6 plus 4, right? The 4 distributes also to the oxygen. 4 plus 3 times 2, 6 is 10 oxygens on this side. We have 2 oxygens here. Why not put a 5 to get 10 here as well? So let's make sure everything is balanced. We have 3 carbons, we have 3 carbons. We have 8 H's, 4 times 2, we have 8 H's. We have 10 oxygens, right? 5 times 2 is 10. We have 3 times 2, which is 6 O's. and then 4 times 1, which is going to be 4 O's, so 6 oxygen plus 4 oxygens is 10. So you have 10, 10, everything is balanced. And that is your basic combustion reaction. That is applying everything that I've discussed so far to writing out a combustion reaction and being able to balance it. Okay, so this should be extremely straightforward for you guys. Now what I want you guys to do, okay, and that basically concludes my discussion on combustion reactions. What I want you guys to do is I want you guys to write me the combustion reaction. Well, I'm going to write it for you because it's pretty straightforward, but I want you guys to balance it for me and put your answers in the comment section below. I want you guys to write me the combustion reaction for glucose. And we'll just put a solid here plus O2 gas. We get CO2 gas plus water liquid. And a few things I want to say about this reaction. As you can clearly see, this is not a hydrocarbon anymore, and that's what I was trying to get at a little bit earlier when I said that it doesn't always have to be limited to carbons and hydrogens. It could also be oxygens, could be thrown in there as well. Realize that as you can clearly see, the oxygen is always going to be the same. It's always going to be on the reactant side. You're always going to generate carbon dioxide, and you're always going to generate water. So just realize those things, okay? The structure for a combustion reaction never changes, though this first thing, the fuel or the hydrocarbon or whatever it may be, can change, but the rest of it stays the same. As you can clearly see, also the state change. It went to a solid, okay? So what I want you guys to do, this is practice, is balance this out. Put your answers for me in the comment section below, okay? I'll be looking forward to your guys' responses. So thank you guys for watching. I hope this all made sense, and stay tuned the next time where I talk about some organic chemistry topics, okay? So thank you for watching. This is MoBaller12 signing out.